So there are quite a few steps we need to process through here. So let x be the height of the portion of the cone that was removed. So what we have here are sort of like two cones that then they had the tops cut off and then they got jammed together, right? So we had to do a lot of thinking about what did they used to look like, right? And figure out the pieces that are missing, because we can't figure out volume if we don't have height. And right now we don't have the height because we don't have a full cone. We have these chopped up cones and we only have pieces that are missing out of them. Let's start by finding the piece of the height that used to be the top of the cone that's been chopped off. So you can see that I drew that on here and labeled it X. And when we had the whole height of the whole cone, that was X plus 12. So with a little bit of cross products and then a little bit of algebra, we end up with learning that the heights, like the height of the piece that was chopped off, was 9.6. And of course we're going to use that over here too. We're going to take 12 and add 9.6 to it, and when we do that we get 21.6. So that 21.6 is useful because now we have the height of, it's hard to say the height of the cone because there is no cone anymore, but we have the height that the cone was before we chopped it off, before we then stuck two of them together, right? Let's go find the volume of the part of the cone that was removed. So that's this piece up here. So we're going to use our volume formula, 1/3 pi, and it's 4, that's labeled here, that's your radius. Let's square it, and then we just figured out that the height is 9.6. So that gives you 153.6 over 3 pi. And then go back to that concept of like this actually was an entire cone when we started, so that's volume equals 1/3 pi 9 squared, right? So here's your 9 down here. We just figured out that the height is 21.6. And when you work that all out, you get 1,749.6 over 3 pi. So we're going to figure out the volume of just one of the truncated cones. So that's basically from here to here, right? We'll take care of the fact that actually we have two of them smushed together. We'll do that in a minute, but let's just do one at a time. So to do that, we're going to take the volume of the whole cone the way it used to be before it got cut up and before it got smushed together. And we're going to remove, so mathematically that's subtraction, we're going to remove that top bit. And when we do that, we end up with 532 pi. Of course, the reality is that's just the bottom half of the hourglass. We need two of those halves. So now we're going to add another one of those. So like you might have gotten confused and thought, oh, I'm done when I had 532. 532 is only this bottom part. You need another 532 pi for the top part. So the volume of sand to fill the entire hourglass is 1,064 pi meters cubed.